So we have two functions here, and we're used to approximate the solution f of x equals g of x by using the graph, and use the graph as a starting point. Now, it's a lot easier to just graph it on the calculator, and it says that we could go up to 3 iterations, which is fine, I suppose, but you could basically what you got to do is take the average of the two. So you're going to subtract the second function from the first function. So let me write it out, and then we'll show you what we're talking about. So if they're equal to each other, if f of x is equal to g of x, then that means that x to the third power plus 3x squared minus 6x, or I'm sorry, minus x minus 6 should be equal to x squared, this is g of x now, minus 3x minus 2. Now we can approximate this by setting it equal to 0, so I'm going to subtract x squared from both sides. Now that's going to give me x cubed plus 2x squared minus 6, oops, forgot about the x, minus x minus 6 is equal to negative 3x minus 2. So now I'm going to add 3x to both sides. And I've got x cubed is equal to, not equal to, plus 2x squared plus 2x minus 6 is equal to negative 2. Add 2 to both sides. And I'm left with x cubed plus 2x squared plus 2x, and then minus 4 equals 0. So now I look at this, and it's pretty darn close to 1, but it's actually between 0 and 1. So what I can do is I can.
Pardon the interruption, high school teachers, could I please have varsity baseball players report to the gym at this time? Varsity baseball, please.
So what I'm going to do then is I'm going to evaluate this between 1 and 2. In other words, or I'm sorry, 0 and 1. So I'm going to say 0 cubed plus 2x plus, I'm sorry, we're going to plug in 0 for x. So this becomes 0 squared plus 2 times 0 minus 4. And so that evaluates to negative 4. Then I'm going to evaluate it at 1. So I've got 1 cubed plus 2 times 1 squared plus 2 times 1 minus 4. And I'm choosing between 1 and 0 because it's right here. So then I get negative 4. So this is 1. This becomes 2 because 1 squared is 1. 1 times 2 is 2. This becomes 2. This becomes 1. 1 plus 2 plus 2 is 5 minus 4 is 1. So I've got negative 4 and positive 1. Now, when I look at this, I see that these are some bounds. Now, the solution exists between the upper and lower bounds. One of those bounds will yield a negative result, and one will result in a positive result, right? So 0 yields a negative. So then what I'm going to do, I'm going to average that out, right? So 0 gives me the negative. In other words, so I take the average of the upper and lower bounds, okay? So I've got 0 and 1. So I started with 0, so now I'm going to take the average. 0 plus 1 divided by 2 is just 1/2, okay? So that what I'm doing is I'm finding out that my solution is pretty darn close it's between 0 and 1. So now I'm going to evaluate it at 1/2. All right. So now if I evaluate it at 1/2, I've got 1/2 cubed plus 2 times 1/2 squared plus 2 times 1/2 minus 4. And we're going to figure out what that is. 1/2 cubed is 1/8. 1/2 squared is 1/4. 1/4 times 2 is 1/2. 1/2 of 2 is 1. So I've got 1/8 plus 1/2 plus 1 minus 4. So then I'm just going to do that in the calculator. I mean, it's 3/8, right? So this, if I make this 8, this becomes 1/2 is the same as 4/8. So that's 5/8 plus 1. 5/8 plus 1 is 13/8, because 8/8 is 1. This becomes 8/8. So I've got 13/8 minus 4, which is really 32/8. 13 minus 32 still results in a negative value. Okay. So now I'm going to take the average of, because it results in a negative value, I have to take the average of 1/2 and 1. So I'm going to say 1, I'm going to choose the upper boundary. We don't want negative. We want to get really, really close to having like a bad hair day or something. All right. So because it results in a negative, I'm going to say 1 plus 1/2 all over 2. So 1 plus 1/2 is 3/2 divided by 2 is equal to 3/4. So now I'm going to evaluate my function at 3/4. We're almost done because we're supposed to do this for 3 iterations. So I'm just going to plug this in the calculator real quick for time's sake, because this video is taking way longer than I want to. So I'm going to do 3. Actually, I could do this in I could do this as a table. So let me clear all these out. And I'll put the function in up at the top. So it's going to be x cubed plus 2x squared plus 2x minus 4. And so now when I hit the table of values, it'll evaluate it for me. So now if I go into table set, I'm going to change this to increments. I want to evaluate this at 3/4. So I'm going to make this incremental in fourths. So that's 0.125. I can plug it in as a fraction too. It doesn't matter. And I'm going to start at 0. So I hit table of values. And so 3/4 is 7/5. It's still negative, right? So now I've got to take the average of 3/4 and 1. So I'm just going to keep repeating this process. It says do 3 iterations plus 1/2. Well, that becomes 7/4 over 2, or 7/8. Okay. So now I go back to my calculator. So we're basically approximating that x is approximately 7/8. So this is a lot of work. You could just plug this in the calculator and do it, but this is what they want you to know. So if I hit second table now, because I've moved to eighths, I'm just going to say 1 divided by 8, which will give me 0.125. So now when I look at the table of values, 7/8 is actually 0.875. As you can see, it's still negative. So now I've got to take the average of 7/8 plus 1. And so what I'm doing is I'm incrementally halving. We started off between 0 and 1, took the average, we were at 1/2, found out it was still negative, took the average of that, we got 3/4, took the average of that, we're at 7/8. And now we need to take 7/8 plus 1 all over 2. This becomes 15 over 16. And so then what we're doing is we're inching up to a positive value. So on my calculator, what I'm going to do is I'm going to evaluate that. But if I hit second table set, now because we've got something over 16, we're going to say our increment will be 1 divided by 16. And now it'll count by 16ths. It'll be a decimal. And we want to get really, really close to 1. It'll be the number between 8.875 and 1. So it's this one here. And so we did all that work, and as you can see, now it's positive. So our approximate value, what is the approximate value of the solution? X is approximately 15 over 16. Now they said just do 3 iterations, and that's pretty close. That's not bad. It's not bad. If we were to do that again, it'd be something over 32, and we would get pretty close to it, but that's all they asked us to do. The easy way to do this is to graph this and find out exactly where it crosses. And your calculator does the same algorithm of taking the average and approximating, and it just does it quickly. It just cranks through the algorithm, but it doesn't hurt to do it by hand once in a while so you guys get an idea of how your calculator works. So that's the answer, 15 over 16.